Can metal be used in injection molding? Injection molding is a manufacturing process that involves injecting molten material, such as plastic or metal powders, into a mold cavity. The material is then allowed to cool and solidify, taking the shape of the mold cavity. Injection molding is commonly used to produce a wide range of products, including automotive parts, toys, and medical devices. One of the key benefits of the plastic injection molding process is that it allows for the mass production of parts with a high degree of accuracy and consistency. It is also a cost-effective cast metal process, as it allows manufacturers to produce a large number of parts quickly and efficiently. While metal powder injection molding is typically associated with plastic MIM materials, it is also possible to use metal in MIM process injection molding. Metal injection molding, MIM, is a common manufacturing process that involves injecting a feedstock, made up of metal powder mixed with a binder material, into a mold cavity. The feedstock is then allowed to cool and solidify, forming a solid molten metal casting process part. MIM offers several advantages over traditional metalworking processes, such as casting and machining. It allows for the production of parts with complex geometries and fine details, as well as parts with a high degree of dimensional accuracy. MIM is also a cost-effective process, as it allows manufacturers to produce a large number of parts quickly and efficiently. Several types of metal can be used in MIM, including stainless steels, titanium, and cobalt chrome. These metals are chosen for their strength, durability, and corrosion resistance, as well as their ability to withstand high temperatures and pressures. One of the key challenges of MIM is ensuring that the metal feedstock is properly mixed and homogenized. If the feedstock is not properly mixed, the resulting parts may have inhomogeneities or defects. To overcome this challenge, manufacturers often use specialized equipment, such as high-energy mixers and blenders, to ensure that the feedstock is properly mixed and homogenized. Another challenge of MIM is ensuring that the metal injection molded parts have a consistent microstructure. This is important, as the microstructure of a metal can have a significant impact on its mechanical properties and performance. To control the microstructure of MIM parts, manufacturers may use a variety of techniques, such as heat treating and sintering. Conclusion. In summary, metal can be used in the metal injection molding process through a process called metal injection molding, MIM. MIM allows manufacturers to produce parts with complex components, geometries, and fine details, as well as parts with a high degree of dimensional accuracy. It is also a cost-effective process, as it allows manufacturers to produce a large number of parts quickly and efficiently. However, there are challenges to MIM, including ensuring that the metal feedstock is properly mixed and homogenized, and controlling the microstructure of the resulting parts.